Alright, so linear law is essentially the process of converting non-linear equations to straight lines. That is done by replacing the x and y axis. We can also call this linearizing a non-linear equation. Let's say for example we have y is equal to 2x squared plus 5. That is a quadratic. If we were to plot this on a graph of x and y, this is what the graph would look like, a curve. But what if we want to plot this as a straight line? To plot this as a straight line, the first step is comparison with y is equal to mx plus c, that is the general form of a straight line equation. By comparison, we realize that y should be plotted on the y-axis and x squared should be plotted on the x-axis. And thus, we compare to realize what we should plot on the x and y-axis. This is why we compare. After we are done identifying what should we plot on the axis, then just identify the gradient and y-intercept. That is, gradient is 2 and the y-intercept is 5. So you have a straight line of best fit when the when a graph of y against x square is plotted. Then, let's say we are given the equation of a curve y is equals to ax exponent b, and we are asked to determine how the x and y axis will be changed to achieve the straight line. That is what we should plot on the x and y axis to achieve a straight line. Alright. So this is the equation we are given. We'll start by writing this down first of all. Now there are two options. That is to use ln on both sides or lg on both sides. My personal preference is that you use ln because graph of ln exists, whereas graph of lg does not exist. Then also apply ln on the right hand side. So you have ln ax exponent b. And realize that there are two things being multiplied in the brackets. And we can rewrite this as ln a plus ln x exponent b. Since the power has another power, it can be multiplied to the logarithmic function. And that is what we'll do to further simplify this. So I can rewrite this as b, just a second, b ln x plus ln a. And the y-axis is ln y essentially. Once I'm done simplifying, I need to compare this with the general form of a straight line equation. Y is equals to mx plus c. Then by comparison, I can deduce a few facts. That is, ln y should be plotted on the y-axis and ln x should be plotted on the x-axis to achieve a graph of a straight line with gradient d and y-intercept ln a, if I'm not wrong. Yeah, ln a. Then moving on, once you all got the concept, there are two types of questions in your exam paper. In the first variety of questions, you will be provided with a non-linear equation and some experimental values of x and y. And you will be asked to simplify this and just convert this to a linear equation. That is a straight line equation. And then plot this. Maybe. Alright. So just like we did in the earlier case. So the first step is to simplify the equation and convert it into the linear form, and then change the x and y axis, and then change the experimental values, plot a line of best fit, and eventually find a gradient and y-intercept and use your gradient and y-intercept to find the values of the unknown. Let's say for example I have this question. I have already solved this in order to save time. I was given experimental values of x and y, and an equation to relate a non-linear equation to relate x and y. And I was asked to specifically plot a graph of LGY against LGX. Thus, I need to use LG on both sides and I cannot use ln as done in the earlier case. Thus, once I have this is what I need to plot on the x and y axis. I simplify this and then compare this with y is equal to mx plus c and realize that LGY would be the y-axis and LGX would be the x-axis as given, and the gradient would be b and the y-intercept would be LGA. And these are the experimental values. I blindly need to amend these experimental values to match what I will be plotting on x and y. For example, in this case, I need to plot LGY against LGX, and thus I use the given values of x and y to find the values of LGX and LGY. For example, I use 1.25 to find 0.1 LGX, and thus when I'll be plotting LGX against LGY against LGX, these are the coordinates I'll be using. Your line of best fit in maths should pass to the maximum number of points in the graph you will be plotting. Alright. We have LGY and LGX on x and y and x axis respectively. Use this straight line to find the gradient and y-intercept. Once you found your gradient and y-intercept, use these equations to find a and b. Using your gradient, find b, and then using your y-intercept, find a. This can vary from question to question. And then the second variety of question will provide you with a linear graph and you will be asked to identify the non-linear equation which has resulted in this graph. The first step would be to calculate the gradient and then form the equation in the form y is equal to mx plus c. Then you will replace the x and y axis as per the graph given. Again, to form an equation, you either need 2 points or a gradient and a point. Then finally simplify and make y the subject of the formula. We'll take three examples. The first example, just a second, is this. So the first step is to find the gradient. And for the gradient, I'll use the formula y2 minus y1 over x2 minus x1. This gives me the gradient. So I have 2 points and I have a gradient, and this is more than enough to form an equation in the form y is equals to mx plus c. Y minus y1 is equal to m whole bracket x minus x1. We will simplify this, and the linear equation we'll obtain is x plus 1. Y is equal to x plus 1. Then the most important step is replacing the x and y axis by what they are. We replace them. This is again a very important step. After replacing the x and y axis, our equation turns out to be ln y is equals to replace x with ln x and plus 1 as it is. So this is our non-linear equation which can be simplified to make y the subject of a formula, and we'll do that. So realize that 1 is equals to ln e, and thus we'll rewrite 1 in terms of ln, that is ln e, ln x plus ln e. I'll highlight this so you can like trace this down in the future. And we have logs at the same basis, thus we can multiply the powers since there is a plus sign in between, and we have ln y on the left hand side. Ln cancels out, leaving y is equals to x e. This is our answer. Then, our second example. So we are given this graph. The first step will always be to find a gradient. Y2 minus y1 over x2 minus x1. And our gradient, as expected, would be negative, turns out to be minus 2. We'll use a point on the line and the gradient to form an equation in the form y is equal to mx plus c. This is what we have. We'll replace the x and y axis. Thus we have ln y replacing the y axis and minus 3x as it is plus 10. Then we simplify this. How can we cancel out ln on both sides? We need an ln. Alright. So realize that minus 3x should be multiplied by 1. 10 would also be multiplied by 1. Ain't it? Yeah. So why do we have ln e? Again, I repeat, minus 3x is multiplied by 1 since we need to introduce ln. Thus, we'll use this fact that both minus 3x and plus 10 are multiplied by 1. Thus, introduce ln e. So, whenever anything is multiplied to the logarithmic function, that thing can be made the power of the power. Using this fact, we have this. When two logs with the same base are added, their powers are multiplied after taking the log and its base common. So power minus 3x multiplied by e power 10. When the bases are same and there's a multiplication sign in between, we add the powers. But before that, let's cancel out ln on both sides. So we have e exponent 10 minus 3x as our simplified nonlinear equation. Now our third example. This seems rather complicated since we have x, y on the x-axis. How do we have y on the x-axis? So. The first step, the sequence of steps will always remain the same. That's the good part about that. But you need to be able to identify the sequence of steps. So we start by finding the gradient y2 minus y1 over x2 minus x1, 4 over 2, and the gradient turns out to be 2. Using a point on the line and the gradient, we can form an equation in the form y is equals to mx plus c. The third step is replacing the x and y axis by what they are on the given graph. That's it. Equals to replace x by xy plus 2y. We need to express the equation in terms. Wait a second. Yeah. So we need to make y subject. Alright. Just a second. So we'll square root both sides. Since we are asked to express y in terms of x, and we aren't asked to make y the subject of the formula. So simply express y in terms of x, and this is what we have. That's it.